Hi everyone, so I'd just like to share a little update video here regarding the drop-in board I'm working on for the BMW i3 inverter. So I've solved the issue with the PWM signals not getting through and just getting three ticking noises basically. That's all good. It basically involved bypassing a small MOSFET on the driver board here. So on each phase there's this little MOSFET which for whatever reason is just off all the time, so it doesn't actually let the low side PWM signals get through. And the weird thing is that this gate driver does not drive the gates directly. It's actually attached to two other gate drivers, so the PWM from that, the actual output for driving a full-blown IGBT, has just been used to drive the signal input of these, which is really strange. I don't know why they've done it like that. Probably just the Germans overcomplicating everything as usual. So, because it is a Bosch inverter. So there's this circuitry here, as well as on the other side of the board, which is attached to that little MOSFET. However, I cannot get that circuitry to do anything. There's no signal on here which would control it. It doesn't matter what the input voltage to the inverter is, whether it's 380 volts or 48 volts, this low side will just not switch on at all. So I don't know what's doing that. I don't know how that circuit works or what's even controlling it, because it was like a complete mystery to me. So I don't know. It's kind of got a voltage divider which is connected to the high voltage battery positive, and there's three of them in a varying layout, so I don't know. So to fix the problem, I just put a shorting wire across the drain and source of that little MOSFET, and the PWM gets through no problem. Which brings me on to my next issue. There's really serious ringing, high frequency ringing across the entire board. It doesn't matter where I sample from, current, voltage signals, just 2 points on ground as we've got just now. And you can see it there, so this is 200 millivolts per division. And if I just scale back a bit, that's like the ringing whenever the IGBT module transitions. So I think that'll be at like either 8 or 10 kilohertz. I can't remember exactly what I set the PWM frequency to. I've tried many different dead time settings ranging from 900 to 3500 nanoseconds. It didn't make any difference, so I'm totally stuck. I'm pretty sure that ringing is seriously interfering with the ability of the control board to actually run a detection on the motor. So that ringing there, to basically replicate that, I just clicked the brake option in the Vesc tool, and that just sort of, I don't know, it sets up some sort of weird PWM which on all three phases, but no current actually flows, I don't think. So if I just go and try and run a detection, if I try and measure the like resistance and inductance, the motor just jumps a bit and I just get an error message. So you have to do it a few times for something to come up. See, that time it came up, but I don't think those readings are going to be accurate. So if I measure the flux linkage now, the motor's not turning, it's just making a humming and hissing noise at the same time, and nothing really happens. And that's 20 amps that I've set there. So I reckon those pulses are making it think there's much more current flowing than there actually is, and it's just not delivering enough current to the motor to actually move it. Even putting open loop commands into it with currents up to 60 amps, it doesn't make any difference. There's just no torque on the motor and it just makes a humming noise. It's like it's unable to generate any meaningful torque whatsoever. So I think I'm going to have to redesign the board. There's a technique which they do at my work when they're designing circuit boards where it's connecting to ground, it's isolated through a ferrite bead. So every mounting hole like that, it would not be directly connected to the main ground plane. It would go through a ferrite bead first, and I think that would get rid of this noise on the board, because it doesn't matter where I put this, even if it was on the motor phases anywhere, it's just 16 megahertz ringing, and it's just absolutely everywhere. So perhaps shielding these phase wires would help, but I really don't know. I didn't seem to make much difference with all this out or in the casing as well. It's still the exact same intensity of the ringing. So what I'm going to do now is just see if this resolver IC is going to work. It does output the excitation signal, so that's fine. So I'll try and set this up, make sure it's working, and then just redesign this whole board. There's a few issues with it anyway. There's a lot that needs to be redesigned, so we'll have to go to, I think, Rev 2 on this, or whatever it would be.